step-off method is ideal for occasional use on short rafters. It's prone to compound error, so it's not ideal for precise work on longer rafters. And also, you can't do the step-off method with the speed square. So, bring your rafter layout skills to the next level by learning how to calculate the line length. In my video on roof slopes, I explained that the tangent ratio is the single most useful way to express roof slopes. And now you'll see why that is. The tangent ratio is the rise per single unit of run. And there's also a ratio for the length of a rafter per single unit of run. A lot of carpenters call this ratio just that, the line length per unit of run. But it's got other names as well. In trigonometry, it's called the secant ratio. The span tables call it the slope factor, and Alberta carpenters call it the slope gain factor, or the SGF. What's good about the secant ratio is that you can multiply it by any run in any units, and it will give you the line length in those units. Here's how to find the secant for any roof slope. First, find the tangent of your roof slope by dividing the rise by the run. Or, if your slope is in degrees, just use the tan key. Then, do Pythagoras' theorem with that unit triangle. Just square the tangent using the x squared key. Then add 1 squared, which is just 1. Find the square root of that number using the square root of x key. And that's the length of the hypotenuse of your unit triangle, which is also your secant ratio for that roof slope. You'll find this ratio in pre-calculated tables and the span book, but once you know how, it's very simple to find it for yourself, for any roof slope with just an inexpensive pocket calculator. If you're using a framing square for laying out your rafter, you'll probably find that it's fastest to calculate the overall line length, mark that on your rafter stock, and then measure and mark your adjustments with the framing square exactly like you do in the step-off method. I recommend drawing a diagram or drawing right on your plans to record every significant number as you go. The overall line length goes from the center line to the building line, so prepare extension and dimension lines to be ready for that number. In this example, we'll also get the line length of the overhang. The run of the projection is already on the plans, and we'll find the run of the rafter by dividing the span in half. Now, to get the line length of the rafter, multiply the run by the secant. It's that easy, and it's dead accurate. Do the same for the run of the projection. When calculating the tangent and the secant, avoid rounding your numbers to ensure that your final result is accurate. But once you have your final measurement, round that to the nearest millimeter, because that's as close as you can actually measure on your tape. While we're doing the calculations, we'll get the total of these two line lengths onto the drawing as well, so that we can avoid compound error by measuring both lengths from the same reference point. Now to lay out the rafter. For this one, we'll use stair gauges. Our 1 to 1.5 slope equates to 2 to 3, which also equates to 200 to 300. The stair gauges can go on either edge of the square. Just make sure that for your measurements, you're aligning the outside edges of the square. The first line to draw is the center line of the ridge. Align your center line with the corner of the board so that a tape hooked on the end of the board will give a precise measurement. Measure along the top edge of the lumber and mark your measurements for the building line and the plumb line of the projection. Carefully mark these plumb lines with your framing square. It helps to label them as you go. Next, shorten the rafter by half the thickness of the ridge board. Measure horizontally from the center line and mark the plumb cut for the ridge. These plans show a rough fascia included in the projection measurement. So we'll shorten the tail of the rafter by the thickness of the rough fascia. For the seat cut, make sure that the bird's mouth ends up no more than 1/3 of the width of the rafter, and that the seat cut is no longer than the width of the top plate. If sheathing is applied before the rafters are cut, extend the bird's mouth plumb cut to allow for the thickness of the sheathing. Mark your bird's mouth cut lines long to make them easier to follow with your circular saw. There's the rafter ready to cut out. Clamp small rafters down for cutting so that you can keep both hands on the circular saw. For small rafters like this one, it's much easier to make all your cuts while the rafter is still attached to the end of a longer board, so that your clamps aren't in the way of your saw. Set your saw depth so that only 6 mm or one sawtooth extends below the board you're cutting. Finish bird's mouth cuts with a handsaw rather than weakening the rafter by overcutting with your circular saw. Your last cut will separate the rafter from the rest of the board after all your other cuts are done. If you're using a speed square for your layout instead of a framing square, you won't be able to step off your adjustments as quickly and accurately. So I recommend calculating all of your adjustments on your plans so that you can go straight to marking the cut lines on your rafter stock. In this example, we have to calculate the runs between the face of the ridge board, the outside face of the sheathing, and the inside face of the rough fascia in order to get the line lengths between the cut lines. To our 500 mm run, we'll need to add 12 mm for the sheathing and subtract 19 mm for half of the thickness of the ridge. This leaves a run of 493 mm between the ridge plumb cut and the bird's mouth plumb cut. From the 150 mm run of the projection, we need to subtract the thickness of the sheathing and the 38 mm thickness of the rough fascia to get the adjusted run between the bird's mouth plumb cut and the tail plumb cut. Now we'll find the secant for our 1 to 2 roof slope. Divide the rise by the run to get the tangent. Square the tangent, add 1, and then use square root of x to find the secant. Our 1 to 2 slope is the same as 50%, 6 to 12, and quarter pitch. Here's the secant for it in these tables. Now multiply the two runs by the secant to get the line lengths that you're going to mark on your rafter stock. To avoid compound error, you will want to pull all your measurements from the tip of the ridge plumb cut. So also put in the running total on your diagram. Now let's lay out this rafter. A tangent of 0.5 equates to the 50% or 5 mark on your metric speed square. After sighting your stock for crown, mark the plumb cut of the ridge right at the top corner of the rafter so that you can hook a tape on the end and pull all of your measurements from that single point. Then, mark your adjusted line lengths right on the top corner of the rafter stock. If you don't mark them on the top corner, your lines will not be in the correct locations. From your tick marks, use your speed square to mark these plumb cuts for a 5 to 10 slope. Then, Measure for the appropriate height of your seat cut and use your square to draw your seat cut 90 degrees to the plumb cut line. Cut out your rafter and check it for fit before making the rest. And that wraps up this video. Now, no matter what slope is given to you or what format it's given in, you can calculate its tangent and secant and quickly lay out an accurate rafter.